Hey everyone, welcome back to another video by Cam Room 5. Today's video is continuation of chemical energetics, and we'll talk about why is energy absorbed or released at all during chemical reactions. We'll talk about the molecular basis of this energy release and absorption. Let's go back to our reaction between hydrogen and oxygen to produce a molecule of water. Let's balance this equation by putting a 2 before hydrogen and a 2 before water. So technically 2 molecules of hydrogen react with 1 molecule of oxygen to give you 2 molecules of water. There's a single bond between the 2 hydrogen atoms, and there's a double bond between the oxygen atom, while there's a single bond between oxygen and hydrogen atom within the oxygen molecule. If we break it down, there are 2 HH single bonds and a single oxygen double bond in the reactant side, while if we count total, there are 4 oxygen-hydrogen single bonds being made. The bonds between the hydrogen atoms in the H2 molecule and the oxygen bonds are being broken down because these are reactant molecules and they are breaking their bonds, while the OH single bonds are being made because that is a product. So bonds are broken down in the reactant side and bonds are made during the product side. Bond breaking absorbs energy, and on the contrary, bond making releases energy. And that is the molecular basis of chemical energetics. Actually, the total change of enthalpy during a chemical reaction is a combination of the bond breaking energy and the bond making energy. The change in enthalpy is actually bond breaking energy minus bond making energy. Bond breaking is actually absorbed, so that is why it's positive, and bond making is released, that is why it is negative. Let's revise the idea based on the rubric values. The HH single bond, the oxygen double bond, and the OH single bond has their own bond energies. The HH single bond has an energy value of 436 kilojoules per mole. The oxygen-oxygen double covalent bond has a value of 495 kilojoules per mole. And the oxygen-hydrogen single bond has its own value, which is 463 kilojoules per mole of the OH single bonds. Now when we see there are 2 HH single bonds, there is one oxygen-oxygen double covalent bond, and there are 4 oxygen-hydrogen single covalent bonds. The HH single bond, when multiplied by 2, gives us a value of 872 kilojoules, and oxygen-oxygen double covalent bond is 495 kilojoules per mole. But on the contrary, the OH single covalent bond is 4 times because there are 4 bonds involved. And since it's a bond made, it is being made during the reaction, it is energy released. That is why I'm putting negative over here. When we add all these values, it gives us a total value of minus 485 kilojoules per mole. The minus means that it is an overall exothermic reaction because the energy released during bond making is more. There is a more negative value involved and less positive value. So it's an overall exothermic reaction after the whole bond breaking making. Let's try another reaction, and this time let's pick the Haber process of making ammonia molecule. When we balance this equation, nitrogen and hydrogen react to give us molecules of ammonia. We can see that the atoms are not balanced. Balancing is really important over here because it is based on the number of balanced bonds. 3 molecules of hydrogen, or you can say 3 moles of hydrogen, react with 1 mole of nitrogen to give us 2 moles of ammonia. And if we look closer, the bonds are represented here. a nitrogen-nitrogen triple covalent bond and hydrogen-hydrogen single covalent bond on the reactant side, while nitrogen-hydrogen single covalent bonds on the product side. The nitrogen-nitrogen triple covalent bond and 3 hydrogen-hydrogen single covalent bonds are the ones that are being broken down. So energy will be absorbed here. And when we count, there's a total of 6 nitrogen-hydrogen single covalent bonds, which are among the bonds being made. So energy will be released when the nitrogen-hydrogen bonds are being made. That is why bond broken on the left hand side are energy absorbed, so their energy will be positive. Bonds made on the product side are energy released, so their enthalpy will be negative. Let's refer to the bond energy values and let's see. The total enthalpy should be bond breaking, which is positive, minus bond making, which is energy released. So bond breaking minus bond making. The nitrogen-nitrogen triple covalent bond and 3 times hydrogen-hydrogen single covalent bonds are the total energy absorbed minus the nitrogen-hydrogen single covalent bonds times 6, because it is going to be released over here. Let's put the values to see that 941 kilojoule for the nitrogen-nitrogen triple covalent bond and 436 times 3 for the hydrogen-hydrogen single covalent bonds is the absorbed value, because energy is absorbed in bond breaking, minus 391 times 6 because that is the energy released. Let's solve this mathematically to see the final and the overall answer of bond breaking and bond making. It is actually 941 plus 1308 joules energy absorbed here. So that is the absorbed value, that is why I'm putting it positive. And minus, when we do it on the calculator, it gives us 2346 kilojoules energy release, because that is the bond making process. When we add that, the final value comes out to be minus 97 kilojoule per mole, which means the overall reaction is exothermic. Let's revise that whenever a chemical reaction begins, there are reactants in the beginning. Reactants involve their molecules where bonds will be broken. Energy is absorbed during bond breaking, and then energy is released during bond making to give us the final products. Now, products could be having higher energy than the reactants, or they could be having lower, and that decides the exothermic or the endothermic. But remember, the graph always goes upwards in the beginning, because that is absorbed. Why is it absorbed? Because bonds are broken down in the beginning. That is why the graph is going upwards. It represents the energy absorbed during the bond breaking process. And then the graph comes downward, because that represents the energy released during bond making process. So the graph goes upwards first, and then when it comes down, it's coming downwards because it's energy released during bond making. Bond breaking is endothermic process and bond making is exothermic process, and the total values of the endothermic and the exothermic nature decides the final enthalpy. The final enthalpy could be exothermic or endothermic depending on the overall values of the bond breaking and making process. In exothermic reactions, you can see bond making releases more energy. In endothermic process, you can see that bond making releases only less energy. So when asked to respond to such questions, always mention bond breaking is endo, bond making is exo, and then refer to the reaction based on the total values of the energies involved here. I hope this idea is clear to us, In the next video, we'll do some fast papers. Thank you guys.